Hi everyone, welcome back to our series. Hope you're doing good. This is Mahesh. In this video, we will look into LeetCode problem number 31, next permutation. So let us look into the statement of this problem. So it states permutation of an array of integers is an arrangement of its numbers into a sequence or linear order. For example, array 1, 2, 3 is given. The following are the list of all permutations that are possible. Basically 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Then the next permutation of an array of integers is the next lexicographically greater permutation of its integer. So this is very important. So more formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. Okay, so if such arrangement is not possible, the array must be arranged as the lowest possible order, that is sorted in ascending order. Okay, they have given few examples. Then they have also stated that the replacement must be in place and use only constant extra memory. Then the constraints, the length of the nums array ranges between 1 and 100 and the number in the nums array will range between 0 and 100. With that, let us switch to our editor and let us try to understand the problem. So now let us consider this particular array 1, 2, 3. So now what we will do, we will rearrange all the elements in this particular array in all the possible ways. So if we do that, then what we get 1, 3, 2. Okay, then we get 2, 1, 3, then 2, 3, 1, then 3, 1, 2 and 3, 2, 1. So these are all the possible combinations. Now what this problem states, they will give any one combination. Maybe they will give 2, 1, 3, then they will ask for the next possible permutation. So if they give 2, 1, 3, then 2, 3, 1 will be the next permutation. So now if you see here one thing, now we have got all these numbers which are rearranged, and if you see 1, 3, 2 is greater than 1, 2, 3. Now if you see 2, 1, 3, it is greater than 1, 3, 2. If you see 2, 3, 1, it is greater than 2, 1, 3. If you see 3, 1, 2, it is greater than 2, 3, 1. So this way they are ordered in a lexicographical order, and in that if they give this particular combination, then we will have to return this particular combination. If they give this one, then we will have to return this one. So this is what the problem states here. So with that, we have also understood the constraints. So basically our array length will be between 1 and 100. Okay, so this is the problem statement. So if this is the case, then how to solve this problem? So if we consider the extreme naive case, maybe before that what you can do, you can pause the video, you can think for any possible solution. Then you can come back and continue watching this video. With that, let us also try to understand the idea or what the interviewer will be expecting. So basically they will give any one array and they want us to return the next possible permutation, and that they want us to do in O of n time complexity and without using any extra space. So basically O of 1 space complexity. So that is the most optimal way to solve this problem. We will look into that later. But before that, let us try to understand what is the brute force solution for this problem. So we already seen, right? I mean, if any array is given, we will try to find all the possible combinations. Okay, then we will sort them. We will sort them in their lexicographical order. If that is the case, then we will get this entire array. We will get basically all the combinations of array. Then we will find which array we want to get the next element. So for this one, this will be the next combination. So we will search linearly for our given combination, then we will take the next combination available. So if we want to do this, then here what we are trying to do, so we are trying to generate all the possible combinations, all possible combinations. So if that is the case, if there are n elements, assume if there are n elements in the array, then to generate all the possible combinations, we need order of n factorial. So if you see, because see here we have three numbers, n will be 3 and n factorial will be 3 into 2 into 1, which is 6. So now we have generated 1, 2, 3, 4, 5 and this is the original combination, which is 6. Okay, so we basically generate, or we basically solve this in order of n factorial, so which is a costly. So this is a small example which contains only 3 numbers, but if you see in our solution or in our problem statement, basically it contains maximum 100 elements in the array. So if we consider 100 elements, then it will be of 100 factorial, which is close to 10 raised to 157 or more. So this is a very costly algorithm just for 10 numbers in the array. So if you consider more numbers, then it keeps on growing like anything. So that's where this solution is not the intended one. So you can simply say, I mean, for the interviewer, so this is a very naive solution for this particular problem where we generate all the possible combinations. Then we will take the next, we will sort it after that. Then we will search for our given combination and then we will simply take the next combination. So it takes of order n factorial, and also if you see, it also consumes extra space. It also consumes extra space. That's why it is not recommended solution for this particular problem. So if that is the case, then what is the optimal solution? What is the optimal solution? So now for the optimal solution, what did we see in the problem statement? We should not use any extra space and we should solve this in single iteration. Okay, so if that is the case, then how to come up with the next possible permutation? So let us take a small example. Okay, let me take 1, 1, 3, 2. Okay. Now we have this particular example, right? We know what is its next possible number, I mean basically the permutation. So basically that will be 1, then 2, 1, 3. Okay, so this is the next possible permutation, and this number, if you see, it is greater than 1, 1, 3, 2, but it is the smallest of all the arrangements which are greater than 1, 1, 3, 2. Okay, what I am trying to say here, if you see this example, now if you see 1, 3, 2, it is greater than 1, 2, 3, correct, right? But we have 2, 1, 3 which is greater than 1, 2, 3. This is also greater, this is also greater, this is also greater. But only thing is, this is the least possible greater number than 1, 1, 1, 2, 3. So if that is the case, this becomes our next permutation. So in the similar case, this will be the next possible permutation because it is greater than 1, 1, 3, 2, but it is the least of the greater numbers in this case. So now the solution for this problem will be kind of like, we will have to observe, I mean, what exactly we get. So basically now if I try to only rearrange last 3 and 2, then what is the number I get? 1, 1, 2, 3. Now if you see 1, 1, 2, 3, it is smaller than 1, 1, 3, 2, correct, right? Then it won't be the next possible permutation. Then these two numbers we have already utilized. If it is not possible with these two numbers, then we will have to consider these three numbers, correct, right? Anyhow, with the last single number, we cannot do anything. So we considered 2 initially. Now we will consider 3 numbers. Now with these three numbers, what I will do, I will keep 1 as it is, first one. Then 1, 3, 2, I will try to rearrange. I can rearrange something like 1, 2, 3, correct, right? But this is not greater than 1, 1, 3, 2. If that is not the case, then what I need to do, I need to check if I can take 3. So I will take 3. Then if I take 3, then 2, 1 are remaining, correct, right? So now if you see 1, 3, 2, 1 is greater than 1, 1, 3, 2. Okay, so it might be the answer, but wait. Now we will see we took 3, but there is also possibility that we can take 2, correct, right? So what I will do, I will say 1, 2, 3, 1. So this is greater than 1, 1, 3, 2, but it is lesser than 1, 3, 2, 1. So it cannot be my answer. So this can be my answer, correct, right? Now, if that is the case, is it my answer? Let's see. Now, here I took 2. I cannot take 1 because if I take 1, again it will be lesser number. That we have already seen here. So now if that is the case, I will leave this number. Next, I will play with the remaining 2 numbers. So we got this value 1, 2, 3, 1. It is greater than 1, 1, 3, 2. Okay, so now I played with this value. Now I will try to play with remaining these 2 values. Now I have 3, 1. I will simply make it as 1, 3. Then I will say 1, 2, 1, 3. Now if you see, this 1, 2, 1, 3 is less than this particular 1, 2, 3, 1. Correct, right? But it is greater than 1, 1, 3, 2. So it means this can be our answer, but this cannot be. Initially we assumed this can be our answer, but that is also not the case. So this is the possible answer now. So which is what we are looking for, correct, right? How we arrived at this one. So basically what you need to observe. So initially I tried to play with one number, but that really did not work. So I played with 2 numbers. Okay. So here I will say I tried to play with one number because we cannot play with one number. So we played with 2 numbers. Then if we didn't get whatever was intended, then we try to play with 3 numbers. Now, one thing what you can observe is, if you see the second number and the first number, from the last I'm talking about. So this number is smaller than this number, correct, right? So this number, third number is smaller than this number, but 3 was greater than 2. So where did we actually replace our number? If you see at this particular place, right? So what I'm trying to say, from here somewhere it was 2, then it went to 3, correct, right? Then suddenly there is a drop from 3 to it came to this 1. So we need this particular drop point. Why? Because that's where we replaced the value, correct, right? We replaced 1 with 2. So now one more thing what we need to observe, how did we replace this number? Basically this was our 1. So if this is our replacing number, I replaced it with 2. Then with remaining 2 numbers 1, 3, I placed them in their increasing order. Why? Because I wanted to get the least possible number. That's where we need to sort them in the ascending order and then we need to place them. Okay, so let us look into this particular example so that it will be more clear. Now what I will do, so basically I will start processing my array from the end. So I will check this first number. So this is 1. Then I will start from this particular number. Okay. So now if I start from here, 3 is greater than 1, correct, right? This is my observation. So then these 2 are in their right position. Now I will go to next number. Now 5 is greater than 3. So if that is the case, they are in their right position. Okay. Now I'll go to next number 6. So again 6 is greater than 5. So it means all these are in their correct position. Now I will go to next number. Again 7 is greater than 6. So all these are in their correct position. Now if you see, this is my 4. So from 7 there is a drop to 4. So it means this is our drop point. Okay, so this is where our number got dropped from a larger number to a smaller number. So now if that is the case, we will have to somehow keep a reference of this drop point. Okay, this is our drop point. So this is one thing. This is the first step. This is what is my observation. Now after this, once here, when I get this drop point, then what I did, I scanned the remaining elements for the number which is slightly greater than this particular number. So here I got 1, but 2, if you see, it is slightly greater than 1. It is the least greater number compared to 1. So that number I took, and then what I did, I swapped it with my 1. So now what I will do here, I will scan from the right again. So here 1 is not greater than 4, correct, right? So I'll ignore. So assume if we try to replace this with 1, so this number will result in a smaller number. So that's where we should not consider the smaller number. Next, if you see 3 is again lesser than 4. So if you replace this with 3, again this entire number becomes less than the existing number. So I will go to next number. Now if you see, we get a number which is slightly greater than 5. Why I am scanning from the right? Because if you see, the numbers are in their increasing order already on the right. That's what I am using. So I'll scan from here, here, here. At this point, I get a number which is slightly greater than my drop point number. Okay, so now I will mark this with my replacing number. So I will simply mark this. This is replacing number. Okay, now once after this, I will simply swap these two. So I will simply swap 4 and 5. Okay, so what I will do, I will swap 4 with 5. Okay, is this done? No, it is the greater number, but it is not lexicographically greater. So what we did, what we saw, we will have to arrange these elements in the ascending order. Currently, it is in the descending order, right? So it is in the descending order, but we want that in the ascending order to get the least highest number, correct, right? So if that is the case, what I will do, I will change all these and I will say 1, 3, 4, 6 and 7. Now I will keep these remaining numbers. So this becomes our lexicographically the next possible permutation. Okay, so this is how with single iteration we come up with the next possible permutation. So step 1, what we did, step 1 is find our drop point where it is dropping. So that is what we did. Then step 2, what we did, find number slightly greater than the drop point number. Okay, after that swap these two. Third step is swap. Then fourth step is simply sort them. So instead of sorting, what we can do, since they are already in their decreasing order, we can simply swap them, correct, right? So swap 1 with 7, 6 with 3 and 4 is 4 with 4 anyhow. So we can simply reverse the remaining numbers, only these numbers, not the entire array. Okay, so this is how we do. So now assume there is a corner case where we have the given array something like this. So whatever the possible combinations you take, this becomes the maximum number, right? Why? Because the numbers are in their descending order, correct, right? So, and if you try to find the drop point, you never find, because always from 1 to 2 there is increment, 2 to 3 increment, 3 to 4 increment. So you don't get the drop point only in this case. So in this case, what we need to do, we need to return the reversed array, because this is the least possible number after rearrangement. So we can simply reverse this particular array and we can return it. So with that, let us also try to understand the time complexity. If you see the time complexity here, what we did, to the max, we process in the worst case the entire array from right to left. Okay, there is only one iteration, and whatever the swapping and the reversing, whatever we do, everything we do in place. So if that is the case, our time complexity will be order of n for this case, and space complexity will be of order 1 because we don't use anything extra. So let us look that in the code now. With that, let me switch to the editor. Let us take a variable int n equal to nums dot length. Okay. Then I will also take a variable drop point. This is where we get where the drop in number happens. So drop point, let us initialize it with -1 initially. Okay, then what I will do, I will do my first step, find the drop point. Correct, right? So for that, what we do, we traverse from right towards left. Correct, right? We should not consider the last number. We should skip the last number. Then we should start from last to last number. That way, I mean, we will have something to compare with. So for that, I will use a for loop for int I equal to n minus 2. Okay, then I greater than or equal to 0, I minus minus. Okay, then what I will do, I will check if my nums of I, if it is less than nums of I plus 1, then it means I got the drop, right? So what I will do here, I will simply say drop point equal to I. So this is where the drop happens. Then I will simply break from here because I should not continue. So this is the first step. Now after this, instead of going to second step, first what we need to do, we need to check the edge case. Correct, right? Edge case is what? If there is no drop point, so it means we will have to check if drop point is equivalent to -1, then this already a maximum number, then we need to simply reverse and give the least number. So for that, what I will do, I will say reverse, then I will have to start, give the start index, that is 0, and end index n minus 1, and also I need to pass my nums array. Okay, so this is how I reverse, and I will return after this. Okay, so this is the edge case. Now we will move on to step 2. Now the step 2, what we need to do, we need to find a slightly greater element than the element at the drop point. So find greater element than element at drop point. Okay, so for that, again I will start from the right. So now this time I will consider the last number also. So for int I equal to n minus 1, okay, I greater than or equal to 0, I minus minus. Now what I will do, if nums of I, if it is greater than nums of drop point, then what we need to do, we need to simply swap the numbers. That's what we did, right? So what I will do, I will swap. Okay, for that I will take int temp equal to nums of I, then nums of I equal to nums of drop point. So basically I will copy this. So I will paste it. Then nums of drop point equal to nums of, sorry, I need to assign the temporary variable. This way we swap the number. maybe what we can do, I will move this logic to a separate private method. So I will say private swap. So basically what and all we need, so I need to use proper word. So I need int 1 comma int index 2, then I need to know the nums array. Okay, in that what I will do, I will move this logic. Why? Because we are going to reuse this logic later for the reverse method. So now what I will do, I will say this I as index 1, this is going to be index 1, then I will copy index 2, this is going to be index 2, this is going to be index 2. So this way I swap the numbers, reverse method, which we will write later. So now once after this, I will simply call swap I comma drop point, then comma nums array. Okay, then after this, after swapping, I will simply break. We should break here, otherwise it will override with this particular, all the greater numbers, it will override with the element at the drop point. So once this is done, next what we need to do, we need to reverse the remaining elements after the drop point. So I will say reverse drop point plus 1 comma n minus 1. So till the last number, and also I need to pass our nums array. So I will write this reverse method. So I will use a private reverse method. So it will take left pointer, right pointer, and maybe our nums array. So with that, what I will do, I will use a while loop. So basically I'm trying to reverse the number. So reversing means point to first number, last number, swap them, then you move the left pointer towards right, right pointer towards the left, again swap them and continue. So left less than right. Okay, then what I will do, I will simply swap the numbers. So this is where I'm reusing my swap method. So basically left comma right comma nums array. Okay, so this is how I swap. Hopefully, this is it. With that, let me try to run and see. I will minimize this. So there is an issue, invalid method declaration, return type require. Okay, so we will have to, this is my JavaScript habit. So basically it is a void method, and even this is void method. With that, let us run. Sorry, so it should be int. I should not repeat this, int, and this is basically int array and int, and it should be int array. Hopefully this is it. With that, I will run. Okay, so this TL is because we did not increment our left pointer and we did not decrement our right pointer here. Sorry for that. And with that, I will, there is again one more issue will happen. So this is because of my JavaScript habit. There semicolons and all are not really considered. So this is accepted and I will submit this. If you see, our solution got submitted successfully. The most optimal way where we solved this problem in O of n time complexity and O of 1 space complexity, that was in place. Okay, so hopefully I was able to make you understand the solution or the intuition behind this problem. So if that is the case, please consider liking my video, and also subscribe to my channel, share this video with your friends, and if you have understood it well, please add that as a comment as well. Thanks for watching.